Good morning. You are all muted. I'm sorry for that. This was done to make the presentation easier and faster. Thank you for your understanding.
Luis, can you hear me? Luis?
Luis?
Can you hear me?
Yes, good morning, Dr. Walter.
Something happened with your voice. You are so...
You are having microphone.
Now try to speak, Professor Luis. Can you speak, Professor Luis?
Yes, I can. Can you hear me?
No, but you have an effect, an audio effect or something like that.
Now it's better?
Now it is like if you were in a hole and it's just with echo.
Is it better?
No.
Hello? Well, it's 9 o'clock in the morning. Good morning, everybody. Be all welcome. Thank you very much for your presence here. It is a pleasure to see you, and it's also a great honor. Please allow Dr. Walter to start with a few words.
Okay. Hello, good morning. Everybody can hear me well? Because I had some problems with the sound just a few seconds ago. Okay. Let me see, I will check everything. Perfectly, so. Okay. We will start, so. Thank you everybody for being there and welcome to the Southern Brazilian Journal of Chemistry International Virtual Conference. My name is Dr. Walter Peláez, and together with Dr. Luis de Boni, we welcome you all to the Southern Brazilian Journal of Chemistry International Virtual Conference. As this is an international conference and we have participants from different parts of the world, it would be nice to say good afternoon and good evening too, because we have people hearing us from Nigeria, from Georgia, from Hungary, and for all parts of Latin America. Now, Dr. de Boni will make the official opening of the conference, and to avoid mistakes and forgetfulness, he has prepared a short video for you. Okay, Dr. de Boni, the audience will listen to you with attention. Can you reproduce the video if you want?
Thank you very much, Dr. Walter. Thank you all for your kind patience. I will share my screen and the video. I hope you all enjoy it. As soon as I find it, just one moment.
Perfect.
Good morning from Brazil and a very warm welcome to the conference to celebrate the 30 years of the Southern Brazilian Journal of Chemistry. I am Luiz de Boni and I am currently the chief editor of the Southern Brazilian Journal of Chemistry, and I have been working on this project since the year 2004. On behalf of the Southern Brazilian Journal of Chemistry, I would like to thank you, all the authors, reviewers, and all the other honorable guests present for gracing this occasion. This opening ceremony was divided in 3 parts: the acknowledgements, the history of the journal, and the future of the journal. Acknowledgements. There are several authorities here today. We will acknowledge them all, but I will start acknowledgements with someone that's no longer around us, the former editor of the Southern Brazilian Journal of Chemistry, Dr. Lavinel Ionescu. Thank you very much for having the courage to create this free and independent journal. Now let's acknowledge some of our international partners. From Georgia, Ilia State University, Dr. David Tarnishvili and Dr. Ketevan KUPATADZE, Zalien Didima Dobla. From Kazakhstan, Stabayev University, Dr. Bolad Kuspanglayev and Dr. Zanar Zujmilinov. KUP Hakmiet. From Russia, Sashenov First Moscow State Medical University, Dr. Oleg Admakin, Dr. Andrei Sebetov, and Dr. Anton Timoshy. Bolshoi, Splasiba. From South Korea, Space, Dr. Song Jong Kim and Dr. Elcio de Oliveira. Behu, Kansa Nida. From Nigeria, University of Ilorin, Dr. Souman Abdul Karim and Dr. Atolani Olubumi. Thank you very much. From Ecuador, Universidade Técnica de Ambato, Dr. Galo Lopes and Dr. Diana Fialos. Muchas gracias. From Colombia, Universidade Distrital Francisco José de Caldas, Dr. Ricardo Duarte and Dr. Fred Sarmiento. Muchas gracias. From Venezuela, Universidade de Los Andes, Dr. Mário Rossini and Dr. Gerson Delgado. Muchas gracias. From Argentina, Instituto de Investigaciones en Físico-Química de Córdoba, da Universidade Nacional de Córdoba, Dr. Sérgio Dacier and Dr. Walter Pelais. Muchas gracias. De Argentina também, La Faculdade de Ciências Químicas da Universidade Nacional de Córdoba, Dr. Marcelo Mariscal and Dr. Walter Pelais. Muchas gracias. From Brazil, Universidade do Estado do Rio de Janeiro, Dr. Ricardo Ribeiro, Dr. Mônica Marques and Dr. Sérgio Correia. Muito obrigado. Universidade Federal do Rio Grande do Norte, Dr. José Melo and Dr. Francisco Lima. Muito obrigado. O Instituto de Pesquisas Energéticas e Nucleares, Dr. Wilson Calvo e Dr. Denise Fungaro. Muito obrigado. O Instituto Federal Sul-Rio-Grandense, Dr. Flávio Nunes e Dr. Daniel Arsandi. Muito obrigado. O Instituto Federal do Rio de Janeiro, Campus Duque de Caxias, Dr. Maria Pinheiro e Dr. Aline dos Santos. Muito obrigado. A Universidade Federal do Recôncavo da Bahia, Dr. Fábio dos Santos e Dr. Jorge de Menezes. Muito obrigado. O Instituto Tecnológico da Aeronáutica, Dr. Anderson Correia e Dr. René Gonçalves. Muito obrigado. Associação Brasileira de Química, Dr. Renato Evangelista and the Master of Sciences, Leandro Camacho. Muito obrigado. Ao Conselho Regional de Química da Quinta Região, Dr. Paulo Falavena and Master of Science, Leandro Camacho. Muito obrigado. to the Brazilian Space Agency, Dr. Carlos Moura and Dr. Fábio Santos, muito obrigado. And from Brazil, our first hosting university, from the state of Rio de Janeiro, the University of Vassouras, Dr. Marco Antônio Soares de Souza, Dr. Carlos Eduardo Cardoso, Dr. Letícia Gomes, and Master of Science Lígia Santos. Muito obrigado. To our team, the ones that I haven't already mentioned, from Romania, Oana Popa, from Portugal, Teresa Roseiro, from Iraq, Shaima Banun and Intsar Sharba, from Indonesia, Adrian Saputra, from Russia, Olga Polezeva, from Argentina, Christian Quintero, from Egypt, Ala Mohamud, from Colombia, Roberto Fernandes, from India, Bhavana Ambukar, and now from Brazil, Rafael Oliveira, Marcos Clank, Mazurquede Coimbra, Paulo Souza, Daniele Moura, Isaac da Silva, Gabriel Rubensan, and Roseli Genari. To the Ethics Committee, Dr. Luiz Alberto de Boni, my father, and Dr. Marco Antonio Goldani, the father of Dr. Goldani. Thank you very much. And of course, to all the authors who have attended to this conference. It would be impossible to make this celebration without you. The history of the journal. The Southern Brazilian Journal of Chemistry was established in 1993 by Dr. Lavinel Ionesco. This journal was created to provide a space for scientists to publish the result of their research. Dr. Ionesco was the editor-in-chief of the journal from 1993 to 2016, the year that I was invited to become the editor. Dr. Ionesco had a great influence in establishing at least 3 scientific journals in Brazil, some of which had achieved results that no other Brazilian journal has achieved before. I met Dr. Ionesco by the year 2003, and I started to participate in this project around 2004. Today, I can say that working with Dr. Ionesco was a great adventure, and I have learned a lot. The way that he conducted the journal was extremely professional and memorable. Every Wednesday morning, we were working on the journal. I still can remember that he used the mail to communicate with the authors. For some reason, he didn't like the email. Nowadays, I understand why. It was very interesting to see the journal receiving letters from different countries, and how hard it was to send them back to some countries, as they were returned by the mail service. Several years later, one day Professor Ionesco told me, "You will be promoted in the journal. Now you will be assistant editor." It was the first time in my career that I was promoted on a job, and it was not a problem that it was a voluntary job. By 2015 and 2016, I was appointed to be the chief editor. And as a stubborn person, I said no, 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 no. But then, life happened, and I couldn't say no anymore. The coming years were a little difficult for the journal, but thanks to the goodwill of the team and the authors, we stand here today together, not as a collection of scientists, but as friends. And as time went by, the journal approached the 30 years. We were thinking about what to do to celebrate. Then one of my colleagues had the idea to make a conference. Please allow me to paraphrase him. He said, "Well, I have a great idea every 20 years or so." Then we start to talk with some friends, and here we are today. God knows how blessed this journal is for having you all as friends. and for your trust in this journal. Thank you very much. Now, let's talk about the future of the journal. As you know, the Southern Brazilian Journal of Chemistry is completing 30 years, and the production cycle has come to an end. It's time to renew our energies, and we will make big modifications in the structure of the journal and in the management style. Starting by the title of the journal, it will change from Southern Brazilian Journal of Chemistry to Southern Journal of Sciences. The journal logo will also change from this to this. These modifications will also be extended to the journal ISSN and possibly to our DOI number. We are working in collaboration with the respective agencies to complete this task as soon as possible. The journal scope is also changing from chemistry and general related topics to science and the related topics. As we prefer an interdisciplinary approach for the journal, it reflects better the path that the journal has took over the most recent period. The domain name of the journal was also improved from sbjchain.com to sjofsciences.com. Regarding the management of the journal, I have learned that it's not good to be the editor-in-chief for a lifetime. Therefore, the new editor-in-chief will work in this position for a period of 2 years, 1 plus 1 year. The new editor-in-chief will receive support from the new assistant editors. The assistant editors will count on the Journal Council support. And as up to this moment, please allow me to introduce the new editor-in-chief of the Southern Journal of Sciences, our colleague from Argentina, from the University of Córdoba, Dr. Walter Pelais. Continuing with the modifications, the new assistant editors with new responsibilities are from Georgia, Iowa State University, Dr. Ketevan KUPATADZE. From Iraq, Misan University, Dr. Shaima Banoum. From Argentina, Maza University, Dr. Christian Quintero. And from Brazil, Instituto Federal do Rio de Janeiro, Dr. Aline Maria dos Santos. This list will grow, and it will be completely available in a few weeks. I will assist the journal by assuming the newly created position of Journal General Secretary. I believe that during this new phase of the journal, we will increase the ties of brotherhood and friendship among our countries and institutions. After these short announcements, I hope that we can keep in touch for the next 30 years. And I declare the conference open. Thank you very much. Sorry. Good morning again. Thank you very much for your patience. Dr. Walter, the words is with you now. Thank you.
Okay. Yes, there is a bit delayed, but don't worry. Okay, so thank you, Dr. BONI, for this introduction and for the good news that you have told us. In relation to the announcement, I am very honored and proud to be the new editor-in-chief of the, and of course, I think I will do my best to carry out this great task. Before we start with the lectures, let me give some advices, okay? During this period of changes, both names for the journal will be applied until the new website is created and all the changes are applied. Remember to visit, of course, you can say that to all your partners. Remember to visit and subscribe to our YouTube channel. There, we'll be able to watch all the conference live, like the videos presentation of the posters, and ask questions to the authors. Also, the conference website will be find extended abstracts, okay, and the author's emails for your request. You can use both methods. Remember that in order to choose the best posters, your participation is very important. See the website for more information, okay? On the other hand, the posters evaluation will receive an email and will have a couple of days to return their opinions. And after that, the winners will be announced. Saying this, we see you in a few minutes at the conference of Professor Zsolt SZAKONYI. We will check that everything is okay. Also, Professor SZAKONYI is connected. Just in a few minutes, we'll start with this conference, okay? Thank you very much.
Thank you all for being here. It was a pleasure to be with you. And, well, it was shorter than I imagined.
I can see,
each other.
I can see Dr. Zsolt there. Just will start. It's a pleasure to meet him again after several months, several years, sorry.
Okay. I will open the microphone so we can all talk now.
Okay, so I think everything is okay, Dr. Zsolt.
You can unmute all.
Yes, thank you. Thank you. I think it's now working. I was unmuted centrally, so I could not open it. It's very nice to see you again, and very nice to meet you, Luis, and also Walter. It's a great pleasure to participate in this nice conference, really. I hope I won't be so much organic. We will see the opinions. We cannot hear you, Walter.
Walter, you're muted.
Walter, you are muted.
Okay.
Yeah.
I don't know why, but it's mute again, so just along. Okay, perfectly. We will start. So, continue with the conference. Dr. Zsolt is here and everything is ready. If something happened, please, sorry. It is a great pleasure for me to have you, Dr. Zsolt SZAKONYI, here, since I worked under your direction some months when I was performing my PhD several years ago. In that time, both Professor Gloria Iranzo and you were great mentors during my PhD, along other people like Professor Ferge Fulop and Professor Albert Georgi from the Budapest, and of course, all of you were my great mentors. Before I let you, to the people present here, before I let you enjoy his knowledge, Noelia, who is doing a postdoctoral position at my lab, will share with you some details of this of his scientific life. Okay.
Okay. Good. Okay, I'm here. Okay. Good morning, everybody. It's a great pleasure to welcome Dr. Zsolt SZAKONYI here. He was born in 1969 in Szombathely, Hungary. He received his master's degree in pharmacy in 1992, and he undertook his PhD in synthetic organic chemistry in the group of Professor Ferenc Fulop, and held his PhD degree at the University of Szeged, Hungary in 1999. He joined the research group of Professor Norbert de Kempe at the University of Ghent, Belgium, in a period of 1999-2000. with a postdoctoral research fellowship granted by the FWO. He became a full professor at the Institute of Pharmaceutical Chemistry at the University of Szeged in 2019. His research interests center on the stereoselective synthesis of mono and diterpene-based bi- and tridentate building blocks and beta-amino acid derivatives. His scientific output more than 80 international publications, and 7 patents with over than 1,300 citations. Currently, he is the Vice Dean in the Institute of Pharmaceutical Chemistry of the Faculty of Pharmacy at the University of Szeged. Today, Dr. Zsolt SZAKONYI will be sharing with us his expertise covering the following topics: stereoselective synthesis, synthesis of chiral aminodiols and amino alcohols, terpene derivatives with antiproliferative activity, and antioselective catalysis. The title of his conference is Stereoselective Synthesis and Antiproliferative Activity of STEVIOL and ISOSTEVIOL-BASED by and TRIFUNCTIONALIZed DITERPENOIDS. Dr. Zsolt, the audience is yours.
Thank you so much for the kind introduction, Noelia and Walter. I really remember very friendly on Walter and Walter period, and I still have his compounds in my laboratory, in my safety place, so we can use them very well. So I would like to share my lecture with you. The title we have already heard, so just a moment, I have to start from the beginning. Yes, exactly, and then sharing. Okay, I hope it can be seen well, and you can listen me. So once more, it's a very great pleasure and honor for me to keep a lecture on your very nice conference, even if it is just an online conference, and normally we know that the best conference is in a real time, real meeting conference, but we hope that, I also hope that very soon we can meet somewhere all over the world in a normal conference in a normal time with safety conditions. So first of all, before I start to talk about the chemistry and the science, I hope I can jump. Yes, I would like to shortly introduce Hungary, which is in the middle of Europe, and Szeged with a small video. You can at least have got any idea where you can find Szeged. Szeged is a small city in the south part of Hungary, close to the Serbian border. It's a very nice city with 160,000 people and a very nice university, University of Szeged, with 25,000 students and approximately 5,000 staffs in there. And you can see now very soon the Faculty of Pharmacy building in the middle of the city, in the center of the city. It's a very nice old building. And there are 5 institutes, and one of these institutes is the Pharmaceutical Chemistry Institute. And you can see now my window where I'm working exactly. And also you can see very soon just a small picture about the city center with a very nice Catholic church in the middle. Okay, and then we can start the real topic. As you know, the discovery of new drugs are very important still nowadays, especially in a special area which are really important in the pharmacy, like anti-cancer therapy, but all the other therapy can be very important. And it's very important point of view that the compound should be based on such kind of natural sources. In this point of view, the stevizoid diterpene type glycoside is a very important and very exciting compound. These compounds can be isolated as a mixture of glycosides in a plant Stevia reubardinia. It's cultivated drugs, cultivated plants all over the world very easily, and we can isolate the mixture of Stevia glycosides in a huge amount, and you can buy this kind of mixture in towns if you want to use this. This kind of compounds having the glycon structure of stevizoid has many different pharmacological activity. Like as you can see, you can find there some anti-diabetic, anti-inflammatory, anti-hyperglycemic, antihypertensive, or even antiproliferative activity. The glycone normally contains steviol structure, but this structure can be isolated only with oxidative or alkaline condition from the original glycosides. If you use the better yield acidic conditions, then the steviol skeleton rearrange, and we can get only isosteviol structure, which is similar but a little bit different. You can see the difference, it's quite big. Steviol has an allylic alcohol function, while the isosteviol has a keto function on the molecule. It will be important later on. And if I could go, yes. And this, because of the easy commercially available compound, the steviol and isosteviol are the focus of many research area and research work. Such kind of isosteviol compound modified on the ring system D have antibacterial or anti-fungal activity. Some of the steviol compounds derived for steviol skeleton has glucosidase inhibitor activity or even anti-tuberculotic effect, or can be used against hepatitis B. Beside this very interesting activity, the other very important area of this kind of compound application is the anti-cancer therapy, because this kind of compound can be used successfully as antiproliferative compounds in the therapy nowadays. You can see here some modified structure. For example, from steviol, you can see very nice, very effective antiproliferative compounds, but also from the isosteviol skeleton, there are known amino alcohol type compounds, which has also very interesting and very active antiproliferative activity on different cancer cell lines. So that was the literature before we started to work this kind of compounds. And our aim was to synthesize, starting from steviol, new amino diol type compounds, amino triol compounds, and also 1,3 amino alcohol derivatives. Also, starting from isosteviol, we plan to prepare a new family of amino alcohols, 1,3 amino alcohols. I must mention that in front, just 2 slides before, I showed you that some of the amino alcohols are known in the literature, but nobody studied the substituent effect on the nitrogen, on the anti-cancer, anti-proliferative therapy. So let's see the real results and discussion part of the lecture. Starting from the commercially available stevizoid, with oxidative cleavage, we could prepare the glycone steviol with 30% yield, which is not so bad. That is known in the literature, this kind of reaction. In the next step, we prepare the methyl ester with diazomethane. Originally, 3 different pathways were tried to get the methyl ester. The first was the diazomethane, the second was methyl iodide, potassium carbonate in DMF. And the second was the dimethyl sulfate in the presence of lithium hydroxide. Although the diazomethane was the lowest yield, but that was the most safety and very fast reaction. As you can see, the reaction takes place within 5 minutes at room temperature with acceptable yields. So having the ester of the allylic alcohol, the next step was a crucial step, the epoxidation of the methylene function. This was accomplished with vanadyl acetyl acetonate in the presence of tertiary butyl peroxide. So vanadyl acetyl acetonate was the catalyst, and the oxidative agent was the tertiary butyl peroxide. And in this case, we observed the highly stereoselective epoxidation process, and we could also isolate it, one diestereoisomer, which is practically was a trans isomer of the epoxy alcohol. Also, in the diazomethane reaction, we can get a small amount of cyclopropionated compound, which is also known in the literature, but could be eliminated quite easily by column chromatography. So We also studied the epoxidation process with different epoxidation agents, like metachlorperbenzoic acid or peracetic acid or perbenzoic acid. Each case, the reaction was very stereoselective, but in the case of dimethyl dioxyran, that was the only when we isolated the other diestereoisomer as a minor component. You can see the ratio was 2:1, but we could isolate it by column chromatography, this minor component, which was perfectly new, not known compound in the literature. And then we studied the ring opening process of the oxyran ring system. In the first step, we opened the oxyran ring with sodium azide, and we could observe the corresponding azidodiols in good yield. And the next step was a very interesting step. It is called as a click reaction. In dichloromethane, in the presence of copper sulfate and sodium ascorbate, the azide function reacts with alkenes, forming this type of triazolodiols in a radioselective cycloaddition process. The epoxy alcohol ring opening was also accomplished with different secondary amines or tertiary secondary or primary amines. This is a nucleophile ring opening which provide the aminodiol type structure. When we studied the ring closure of aminodiol structure with formaldehyde, we observed that the ring closing process goes on highly stereoselectively, resulting exclusively the spiro type oxazolidine compound. Certainly, originally we suppose that the processor will be not stereoselective. We could get the spiro compound, or we could get the fused 1,3-oxazine type compound, but we observed that the reaction was highly stereoselective, and only the spiro compounds could be isolated and determined in the NMR spectrum of the crude product. When we opened the oxyran ring with propargyl amine, then we can get the corresponding propargyl substituted aminodiol, which underwent also click reaction to provide for us triazolo substituted aminodiol structure. When we prepared the N-benzyl aminodiol type compound starting from the 2 diestereoisomers of epoxy alcohol, in the next step, by catalytic debenzylation, we could observe also the primary aminodiol structure. So practically it means that we could prepare the primary amino function aminodiols, we could prepare the secondary amino function, and also in few cases, as you could see it before, we could prepare also the tertiary amino function substituted aminodiols. And then the next step, we tested these compounds in a panel against a panel of human adherence cancer cell lines. In the first experiment, 4 human cancer cell lines were checked. Shiha and Hela were cervical cell line, human cell line. There was 1 breast cancer cell line and 1 ovary cancer cell line in our test. And it was also clear for us that the alkyl substituted aminodiols, also the primary aminodiols, and even the triazole functionality compound has no activity in either of the cell lines. So they have practically no anti-cancer, anti-proliferative activity. The pleasant was when we studied the same cell lines, the secondary aminodiols, which contains such kind of benzyl substituent under nitrogen, because we find a very nice activity against practically all the 4 cell lines. And you could see here the best compound, which was the alpha-methylbenzyl substituted aminodiol. It's 19. You can see here, which has got the best results on HeLa cell line with the IC50 3.96 micromolar concentration. So that was very, very promising. So therefore, the next question was that what happens if we insert a new chiral center and a new polar functionality group on the STEVIOL structure in this position. To do this, we started from the original STEVIOL molecule, and we did allylic oxidation in the presence of selene dioxide as co-oxidant with tertiary butyl peroxide. This was a nice reaction, and we can get the compound 24, which is a double allylic alcohol type structure with a defined stereochemistry. This oxidation, allylic oxidation, also went on highly stereoselectively. Then we prepared again the methyl ester, epoxidation, the same procedure as it was discussed before, and we can get exclusively this nice epoxydiol structure, which was underwent ring opening with nucleophiles, and we could prepare a new library of amino triol type isosteviol derivatives. And also we prepared not only the tertiary, secondary amines, but also the primary amino triol structure was obtained by palladium catalyzed debenzylation. And let's see the results. It was also clear that the N-benzyl or alpha-methyl benzyl type compound has such kind of activity, even if it is not so good as for the amino diols. But in the case of alpha-methyl benzyl substituted amino triol, we could see quite a nice activity as well. You can see in the red lines, inside the red lines, the results. And we could also realize that this kind of compound has such kind of selectivity on the different cancer cell lines, was not effective on the cervical cell lines, but was effective on the breast and the ovary cancer cell line tissues. So in the next part of the lecture, I would like to talk about the synthesis of amino alcohols based mainly on isosteviol structure. So as I mentioned, isosteviol can be prepared from stevizoid glycoside with a simple acid catalyzed hydrolysis. In this case, we could get a very good yield. The yield was over 90%. So, and that was excellent starting material because we could prepare the starting material even 10 or 100 gram scale. So the first step was an aldol type condensation, followed intramolecular reduction with formaldehyde, and we could get this nice diol type compound in a stereoselective addition reaction. The following step was similarly the methyl ester preparation, followed by regiospecific oxidation in the presence of TEMPO as a co-catalyst, N-chlorsuccinimide and tetrabutyl ammonium bromide as a phase transfer catalyzer in dichloromethan water mixture. With an excellent yield, we could get this hydroxyaldehyde type compound. This aldehyde function was transformed to the oxime, and the oxime was reduced with Raney nickel catalyst in hydrogen atmosphere with excellent yield to providing the amino alcohol function as a primary amino alcohol. In the next step, we prepared also a nice family of secondary amino alcohols. Once we did first the Schiff base formation, reacting the aldehyde function with primary amines, followed by borohydride reduction, and this way we could prepare 1,3 amino alcohols. The other way was the opposite steps. So the first we reacted aldehydes with the primary amino function, and the resulted Schiff base were reduced also with sodium borohydride to providing another family of 1,3 amino alcohols, as you can see in the table below, the special substituents. So this way we could prepare secondary amino alcohols in good yield with different benzyl methyl substitution. The other way we could prepare amino alcohols starting from isosteviol was the monic type condensation of the methyl ester of the isosteviol, which underwent in the presence of secondary amine hydrochlorides, paraformaldehyde in glacial acetic acid with a long reflux. Normally this is much more longer than usually used for monic condensation. And we observed the formation, stereoselective formation of amino ketones with acceptable yield. It was a little bit big surprise that when we applied dibenzyl amine hydrochloride as amine source, we observed not the dibenzyl substitutive compound, but the N-methyl and benzyl substituted amino ketone. That was quite a big surprise for us. The yield was very, very, very weak, as you can see on this slide. And therefore, we find out a mechanism which can be used to explain the reaction results, a very strange reaction result. So probably the first step, the dibenzylamine react with formaldehyde. This is a formyl addition followed by water elimination, forming this iminium salt, which drop down, which undergoes the other formation. This is not so good. It's a missing slide somehow. But formation of the double bond movement to the benzyl function. Benzylidene functional group is formed in this reaction, followed by water addition. And then the last step is the elimination of benzaldehyde, forming the N-methyl and benzylamine in situ. And that N-methyl and benzylamine goes on the monic condensation, forming the N-methyl and benzylamino ketone. The prepared primary amino alcohol was reacted with phenylisothiocyanate in dichloromethane, resulting the expected thiocarbamide, which was reacted with methyl iodide, forming the methyl ether, the corresponding thiourea. And we expected to get ring closure by the nucleophilic attack of oxygen and this carbon, but that did not happen. So this was a big surprise for us because this reaction is very well known in the literature and goes without any problem, but probably because of the steric hindrance of the isosteviol skeleton, this reaction cannot go on, and we has got back the original starting material. And that was the same situation when we reacted the thiocarbamide adduct with hydrogen chloride containing ethanol. Normally, this reaction also goes on very fast, normally just within 1 hour, to get the corresponding phenylaminothiazine ring system. But in this case, we also observed only the formation of the ethyl ether, ethyl thioether of the intermediate, not the ring closed product. So we prepared the amino ketones, and the next step was the reduction of the amino ketones toward amino alcohols, which went on sometimes stereoselectively, sometimes less stereoselectively. A few cases we could isolate the main component as the trans amino alcohol function, but in few cases we could isolate it also the minor component, the cis amino alcohol moiety. We also made a study of the prepared amino alcohols on 5 different human cancer cell lines, on HeLa, SHIHA, MCF7, 233, and A2780. And as you could see, it was a very pleasant surprise that the N-benzyl substituted or different N-benzyl substituted amino alcohol have a very nice activity on different kind of cancer cell lines. Here you can see the IC50 values of each compound. And you can see that the best compound was the parafluoro benzyl substituted amino alcohol, was the best in this queue. In this case, the IC50 value was 2.55, 4.19, or on MCF7, 4.4, and in 231 cell line, this is a breast cancer cell line, even 2.14. So it seems that in this moment, this is the best compound we could prepare. And now the modification of the Easter function is in progress to get better, even better compounds, which could be really good in the treatment of different kind of cancer cell line, human cancer cell lines. We also decided to prepare radioisomeric amino alcohol synthesis, and that you can see on this slide. In this case, we started from the originally prepared epoxy alcohol, which was used for the synthesis of aminodiols originally, treated this epoxy alcohol with bortrifurid iterate in dry toluene. Within 1 hour at room temperature, the ring rearrangement goes on, and we could observe the formation of the corresponding hydroxyketone. But this hydroxyketone is the radioisomeric hydroxyketone, to that one we discussed earlier. In that case, the hydroxymethyl function was here, in this position. So those compounds are radioisomers. Starting from the keto function, we prepared the oxime function quite easily with good yield, and the reduction of oxime function over Raney-Nikel catalyst at room temperature and normal pressure, we could observe the formation of mixture of 2 diastereoisomeric amino alcohols, which could be separated, fortunately, by column chromatography successfully. And then in the next step, we prepared the N-benzyl substituted amino alcohols successfully. So, summary of my lecture, we could dissolve stereoselective synthesis the STEVIOL-based aminodiols and aminotriols, and this compound has quite a nice anti-proliferative activity. We also prepared diterpenes with triazole functional group. We synthesized ISOSTEVIOL-based 1,3 amino alcohols, and the cytostatic effect of aminodiols, aminotriols, and 1,3 amino alcohols was studied on human cancer cell lines. And this topic looks very interesting, and now we are working on the structure activity determination of the substituents effect on the anti-cancer activity of our molecules that will be published in the future, as I hope. So thank you so much for your kind attention. This is the last slide with acknowledgement for the financial support. And I would like to show on the last slide the University of Szeged main building. You can see here, this is really in the center of the city. Szeged, as Walter knows it very well. And on the bottom, at the door of the university, you can see this nice statue of Albert Szent-Györgyi, the Nobel Prize Science, who was working at the University of Szeged when he earned the Nobel Prize, the medical Nobel Prize in the last century. So once again, I would like to thank the possibility, the opportunity to keep my lecture, and I'm waiting for your question. Thank you so much.
Wow, wow. As always, Dr. Zsolt, it's incredible your job. I admire your job, really, I like it so much. So, the audience. Does the audience some questions for Professor? With the presentations, Dr. Luis De Boni. I have some question, but I wanted just to wait for the audience to say something.
Guys, thank you very much. I would have a lot of questions, but I am a little bit nervous. So I will stay quiet to avoid any problem. Thank you very much.
I have a lot of questions because I am organic synthetic, but as some of you know, I moved to the physical chemistry. So I am quite something like a organic physical chemist, something like that, a mixture. I am not an organic synthetic pure, and I am not physics pure. So physical chemical pure. So I have some questions. Dr. Zsolt, I remember when I was there working with you that almost all compounds were prepared in racemic, if you want, mixture, or just the mixture of the isomers. But did you get some methodology to try to purify one of them in enantiomer, or just separe some samples from the diastereomeric mixture?
Thank you, Walter.
Something like that. Okay.
Originally, we don't have this kind of problem because the original molecule is chiral one. So the STEVIOL is a chiral molecule. So if you make a new chiral center, you've got maximum diastereoisomers. That happened few cases, like in the case of epoxidation of the allylic function with the DMDU, dimethyldeoxyran. But in that case, you can separate these compounds very easily by column chromatography.
With column chromatography, perfectly. I remember that was a hard work.
Like always. But fortunately, the compound is quite available. So if you want to use a mixture of stevizoid glycosides, you can buy, let's say, $100 1 kilogram.
Yeah.
So it's not so expensive. From China, you can buy 200 kilograms.
With the time, all of the starting compounds will appear in the industry, and you can get. But I remember when I was there, that's one of the things that we always think that the starting compound was in that moment just more than 20 years ago. I don't remember exactly. That was not so cheap, or just they were quite expensive. So we try to recover everything and don't dismiss and don't put out a lot of the starting compounds. And the other question that I have is do you think that which of these compounds you can just to translate on a pilot scale or just to the industry? Which of them do you think that it's possible to scale to a great scale? Sorry.
Mm-hmm. Yes, the 1,3 amino acids are those compounds which could be very easily prepared in a large scale in industry, because from the mixture of glycosides you can prepare isosteviol excellent yield, so over 90% yield. So if you use 1,000 grams of glycoside mixture, you can get 40 grams of isosteviol glycol, which is very good yield. And then all the steps we did could be increased to industrial level, I believe.
Wow, yeah, sure.
And the amino acids are very promising. Now the understanding of the aryl benzyl substitution and the different kind of benzyl substitution on the molecule, that is under investigation. So we just studied the effect of the alpha methyl, alpha ethyl, or the naphthyl ring system, or substituted naphthyl ring system, or other aromatic ring system. It seems clearly that the benzyl substitution, so such kind of aromatic substitution on the amino function, is essential for biological activity. That's clear.
Wow, very good, very good. I always say to my student here that, okay, you can work with aromatic compounds, but if you are working with just unsaturated or partially saturated compounds, it's really complicated and not so an easy task. But I learned a lot of things from you, and now I can prepare something just quite easy. And the people and my students say, "Oh my, it's incredible!" But really, it's a very interesting chemistry. The idea to prepare compounds saturated, because of course the aromatic things, the aromatic compounds are more easy to prepare. I remember that.
Also for us, it was a big step, you know, that starting from monocyclic compounds like cyclopectine, cycloactine, go to the monoterpenic system, and now from the monoterpenic system to the diterpenic system. That's totally different stage. So if you just want to check the NMR spectroscopy, the mass spectrometry, fragmentation, and so on, totally different.
Yes,
much more difficult.
I remember that from that moment that I had some compounds, and I always tried to purify just to separate the mixture and try to get some crystal. And of course, I never get it. But I think after, of course, have pure one of them, I will do. Because I am interested in the RX, because we know that we work just with computational chemistry and we want to model these kind of things. But of course, it's better to have the crystal, but not always is possible when you are working with saturated compounds. That is true. Okay. Yes. Just we have to say, thank you very much, Professor Zsolt SZAKONYI. That is a pleasure for me meeting you again. And you look like young, like when I was there. What happened? I am older. And please, we will just wait some minutes. We will be a break. And we hope to see you again just for the next conference. And please, thank you very much, Dr. Zsolt SZAKONYI, and I hope in the future see you personally again.
Me too. I also want to see few people, students also in Hungary in the future.
Sure. I always say prepare your baggage, because you will go to travel to Hungary, and that's a very nice country. Okay, thank you very much to everybody, and see you in a few minutes. Okay, see you later.
Thank you very much, Dr. Zsolt. See you in a few minutes. It was a pleasure to see you all.
Yes, in the web page. Don't remember that in the web page. No, you remember, please. Sorry, you will remember that in the web page there is a chronogram that you have checked the next conference, the time of the next conference. Okay, see you in a few minutes.
Yes, next conference will be in Brazilian Standard Time at 10 hours and 40 minutes. I will share my screen.
Okay, so this is a virtual coffee break. As you see, you can say that. I can go to some coffee. Okay, I will drink someone. See you later.
See you soon. Thank you very much. Thank you all for being here, and apologize me that I didn't said it before. Thank you all that have come later.
Yeah.
In some countries, it's very late.
Like half an hour. We will see just in half an hour, something like that. Okay. See you later.
Perfect.
Doctor. See you later.
Bye-bye. 2 minutes to start the next presentation. Thank you very much for your patience. I also would like to say thank you all for being here. Ketevan, Dr. Zsolt, Anton, Dr. Zanar, Dr. Ricardo. It's a pleasure to see you all here.
I have some delay in my internet, something happened. But still, I hope that I will appear in a few seconds.
You will, Walter, you will.
Yeah, sure. I will close the other things, maybe could be that.
Also, I would like to thank you, Dr. Imeda, Dr. Lígia, Dr. Fungaro, Dr. Shaima, Oana, Dr. Lazin, Guilherme Dutra, Diana Coelho. Nice to see you. Well, Karina is my wife. Thank you. Dr. Jorge, Christian Quinteiro, Aline, Dr. Amar, thank you very much. I can't say your name because I can't read Arabic, but thank you very much. Dr. Narsen, Gabriel, Dr. Lima, thank you all. Now, I believe it's time for we to start. And it's an honor for me to have the opportunity today to introduce our colleague from Ilya State University, Dr. Ketevan KUPATADZE. Dr. KUPATADZE has completed her graduation in 1993 in ARGÜELLO University in the Faculty of Natural Sciences with a specialization in chemistry and biology. In 1997, Dr. KUPATADZE completed her master's degree in the same university, and in 2008, she defended her PhD. She is the author of more than 70 published scientific papers and the author of 3 educational virtual programs in chemistry and biochemistry. In addition, she authored over 200 scientific popular articles in chemistry. And additionally, she has worked with us in the project of the journals for many years. I believe that much more than 1 decade. So thank you very much for your dedication in over 2 decades. And now, Dr. KUPATADZE, the word will be with you. And I will just yes, I believe that now you can share your screen. I'm sorry. Thank you very much.
First of all, greetings from Georgia country, from Tbilisi, and thank you, Luis, for this great opportunity that today we are together from different parts of our planet, and we can talk regarding chemistry. Also, many thanks to you for give me opportunity works with journal with different size, because as you told, many years I was an author in this journal, and now I can have a collaboration in different part, and I will do my best. Now I will share my presentation. Can you see it?
Yes, yes, Doctor.
Okay. So today's presentation is deal with the overview of air monitoring in Tbilisi, capital of Georgia. according the date from 2018 till 2021. According data received by this period of time. But before starting talking regarding this topic, I will present very briefly Ilia State University. Ilia State University is...
Sorry, Dr. Ketevan.
Yes.
One thing, maybe it switch off or something happened, and I can see the PowerPoint presentation, but not in a full screen. Can you just
just a
button at the bottom, and you have near to this minus sign at the bottom, you can do
like this
perfectly.
Perfect.
Okay.
Perfect.
Okay. So Ilia State University is young university, is established 2003 with in the base of two ancient Georgian university, pedagogical university and University of on the base of two pedagogical university. There is this is at the same time research university. What is a mission of Ilia State University? Is a mission of to create, transfer and apply knowledge for the purposes of scientific advancement and societal development at the local as well as the international level. What is a vision? Ilia State University will be the leading and rapidly developing research university in Georgia and the entire region by 2024, creating the basis of scientific and technological progress, high standard educational process, and public well-being throughout its innovative approaches. There is a School of Arts and Sciences is one of the oldest academic schools at Ilia State University that offers interdisciplinary education at all levels, bachelor's, master's, and doctoral, basing its curricula on a liberal arts educational model. Second one is School of Natural Science and Medicine. This is my faculty. I belong to this school. Is a new but a rapidly growing school, reorganized in 2014, offering programs at all three levels, also to students and researchers. Faculty of Management, Technology and Education is an umbrella faculty and a brand new home of study programs of business, engineering, and educational schools, including technology courses, labs, and services. The new faculty offers interdisciplinary and multidisciplinary approach within technology, business, and educational field, and changing synergies and close links between the disciplines integrated into the teaching and learning process. And the last one, this is a School of Law, was established to prepare legal knowledge workers and practitioners. As a school emerged one of the successful counters for legal educational in Georgia. There is some research institutes in scope of our university. This is a National Astrophysical Observatory, Institute of Earth Science, Institute of Biophysics, Fundamental and Interdisciplinary Mathematics Study, Theoretical Physics, Chemical Biology, Sleep Wakefulness Study, Institute of Ecology, Child Development Institute, Political Science, Demography and Sociology, Medical Researches, Oriental Study, Botanical Institute, Psychology, Philosophy Institute, also Institute of Zoology, and Institute of Linguistic Study. And we have a quite huge international cooperation. You can see in this slide, and I'm very glad that with this international cooperation. Southern Brazilian Journal of Science also is in this list. Now,
Doctor, your microphone is switched off. You are muted. Sometimes happened to me, you remember?
Your microphone, yes, was turned off.
Yes, in the bottom part, okay, there. Now just in the Zoom window, at the bottom, in the left, you have the microphone, and there, sure, it has a crash line saying that you are muted.
Bottom
here
left.
I have.
Okay, perfect.
Perfect.
Now you can
yes, there was a problem because I was not able to see myself, and that's why it was impossible to find the microphone. So,
but
what
with your presentation again?
Maximize the presentation.
You can't see a presentation?
We can, but not in full screen.
Ah, sorry.
Perfect. No, don't worry.
Thank you. Perfect.
So my microphone is working, I hope, because yes?
Yes.
Okay. So air pollution is one of the major environmental challenges facing the modern humanity. And the atmospheric air is polluted with the harmful substances emitted from anthropogenic and natural sources. Especially in Georgia, we have this pollution due to anthropogenic factors. The key sources of air pollution are the following: transport, power generating, industrial, and agricultural sectors. According to World Health Organization, Georgia does not meet standard of this some of countries, and among of them Georgia can't meet the standards of this organization, and the problem of free air pollution in Georgia has been observed in the largest city of the country, as well as in extensive industrial facilities or industrial zones. Air pollution is associated with many human health disorders, including lungs, cardiovascular, and nervous system disease. And this is a big problem in our country because there is a lot of lung cancer. Every third person, it has this problem, lung cancer, and human health effects are individual. High-risk groups such as elderly, children, pregnant women, and people with chronic heart and lungs disease pros to be more susceptible to air pollution. This presentation, as I told at the beginning, provides an overview of monitoring results conducted in Tbilisi for the period 2018 till 2081, and there will be presented the methodology and some results. And as I told, the many factors is anthropogenic in our country. And I will present a short video. This is a very famous construction in Tbilisi, and they build now these buildings, and you can see how this work. So it's spreading in open air, dust and the PM particles. Results from automated air quality monitoring stations show that particulated matter, PM10 and PM2.5, and nitrogen dioxide represent problematic pollution in major cities of the country. The data was taken from the National Environmental Monitoring Agency website, being displayed online. And also data is obtaining by remote sensing. And regarding remote sensing methodology, I will be talk a little bit later. This is how it looks like the page of National Environmental Monitoring Agency. It's cover all Georgia, and user can choose a city or location from where he wants to receive some data. So it looks like this. As I told, the main pollutants, there's oxides and heavy metals as well, especially lead. Monitoring of atmospheric air pollution in Georgia started in the 60s of last century. For years, observation kept on non-automotive stationary stations. Since 2013, the National Environmental Agency has begun to modernize the observation network in accordance with modern requirements. Since 2016, in the regions as well as in the capital, new non-automatic stations are replaced by modern automotive stations and installation of new additional stations. That's why important to make some remote research. Because with this methodology we can discover the situation obtaining the historical data before of for example 2016 and after also, and we can compare this data with real-time data obtaining by sensors. Monitoring of atmospheric air pollutants is carried out continuously during 24 hours on automatic stations. Data flow from automatic stations is continuous and are kept directly in database and shown in web portal, and the following web portal. So according to the research is the main so according to the methodology, the main sensors which are used in Georgia, you can see in your screen. With these sensors, they allowed to analyze the main pollutant, e.g. sulfur and nitrogen oxides, CO and CO2, ozone, solid particles, and so on. And let me, I will introduce very briefly these sensors. So SO2 analyzer, which is used by a national agency. And by the way, we are also going to make our own research by and we will start in the May in the future May, because I am involved in the NATO project. This project is we are doing by financial support of NATO science program, and we also are going to make alarm web page where immediately will occur if some part of our country the pollution level will be dangerous for health or some other direction. The model, so the model T100 uses a proven ultraviolet fluorescence principle coupled with the state-of-the-art user interface to provide easy, accurate, and dependable measurement of low-level CO2. After you can see this is a description of this sensor. The second one is the Teledyne T200, and it can analyze every kind of nitrogen dioxide, what is very important for our country. The next one is a CO analyzer, and at the same time it can analyze carbon dioxide. This is quite important of some, especially some Georgian cities where there's some factories, for example. So the name does not mean for you. There's a small cities like Rustavi, where the pesticide factory or some metallurgy factories in SZAKONYI and like this. So for small cities, these CO and CO2 analysis sensors are very important, and we have also them in these cities. Some sensors PALAS feed us for solid particle determination, solid particle, PM particle, which is spreading by human activities, and especially the big problem is in TBILISI, in construction places, and I present to a short video, and the similar facts are in every part in TBILISI, because now we have a lot of construction process building, and unfortunately nobody controls it. What is very important in scope of methodology and what we did ourselves, this is a remote sensing, air quality monitoring from the other angle, remote sensing, and air quality and composition of the atmosphere would allow this methodology to us. Ozone layer and ultraviolet radiation, exhaust and surface flows, solar radiation, and climatic impact. Atmospheric monitoring service allows to regional air quality maps and data, retrospective assessment of air quality, identification contaminants and dangers, determining the concentration of plant dust in the atmosphere, evaluation of possible emission management measures, air quality forecast, health information, and risk assessment. Emergency management service. The Copernicus Emergency Management Service is managed through the European Commission and mediated by the Joint Research Center. The service provides customers with information on floods, forest fires, and other human-caused disasters, prior notification systems, the European Flood Awareness System, the European Forest Fire Information System, EMS mapping system, which provide customers with geospatial information made from satellite imagery. Maps are compiled about man-made disasters and environmental pressures. There's a different satellite, but for analysis, for receiving data regarding air atmosphere and its pollution, works 2.1. This is a Sentinel-4. and Sentinel-5. They are absolutely free, and with the appropriate program, we can receive data from them and after make the analysis. Sentinel-4 key features, so 8-kilometer resolution, repeat visit in every 60 minutes. Atmospheric chemistry missions will be running so from this year, 2022, provides data the atmospheric monitoring service of Copernicus climate change service. Sentinel-5P, predecessors of Sentinel 5768 resolution, repeat visit in every 1 day. Atmospheric chemistry mission launched in 2017 provides data, measures the chemical compositions of the atmosphere, namely ozone, nitrogen dioxide, sulfur dioxide, and formaldehyde aerosols and other aerosols as well. Mainly the following pollutants are investigated. So these pollutants are being investigated in Georgia, and they are a main pollutants in for our atmospheric air: solid particles and dust, nitrogen dioxide, ozone, sulfur dioxide, carbon dioxide, and benzene. And I will make a brief description of them. PM, abbreviation PM, particular matter, small particles of gas, dust, or other matters, including thin droplets of liquid. Sources: diesel engines, thermal plants, industries, dust scattered by wind, wood stoves. Health effect: eye irritation, asthma, bronchitis, lung damage, cancer, heavy metals poisoning, effects on the cardiovascular system. Nitrogen dioxide, reddish brown, highly reactive gas. Sources: motor vehicles, electric facilities, and other industrial, commercial, and residential facilities combusting liquid fuels. Health effect: susceptibility to respiratory infections, lung irritation, and respiratory symptoms like cough, chest pain, difficult breathing, and like this. Ozone, gaseous pollutant formed in the troposphere. Sources: exhaust gases from vehicles and other smoke releases formed from other pollutants with solar light. And we know that ozone is one of the main participants, one or the main agents for forming photochemical smoke. We don't have in Tbilisi photochemical smoke, but this is a big problem for other big cities in the world. Health effect: eye and throat irritation, cough, respiratory tract problems, asthma, lung damage. Sulfur dioxide, this is a colorless gas. When dissolved in water, evaporates, forming sulfur acid and interacts with other gases and particles in the air. Source: thermal coal plants, oil refineries, sulfuric acid production, and melting ores containing sulfur, where this is in these ores, it can reflect it after contamination of some kind of other elements. Health effects: eye irritation, eye watering, weight in chest, shortness of breath, lung damage. Carbon monoxide, colorless and odorless gas. Source: exhaust gases from motor vehicle, inner sources including kerosene and wood stoves. Health effect: headache, reduced mental awareness, heart attack, cardiovascular disease, fetal development disorders, and it might be fatal also like that. Benzol has sweet smell. It's a colorless, volatile, and easily flammable fluid that is easily dissolved in the water. Sources benzene is extracted in the air as a result of combustion of coal and oil products, petrol stations, and automobile emissions. Health effect in humans acute in short time, but it's happened. Inhalation may cause dizziness, headache, irritation of eye, skin, and respiratory tract. As for high concentration inhalation, loss of consciousness, chronic, long-term absorption can cause different disturbance in the blood, including reduction of red blood cells and aplastic anemia as a result of bone marrow damage. Now, briefly regarding results, what kind of results we obtained by sensors and by remote sensing. According to the 2018 data, atmospheric air pollution was monitored at 3 stationary bloods located in some kind of streets, so Kunikhadze, Tsereteli, and Moscow Avenue in Tbilisi. So there is a lot of traffic every time, and that's why they was chosen. The following 6 polluting ingredients were determined at Kunikhadze Street: dust, sulfur dioxide, carbon dioxide, nitrogen dioxide, ozone, and lead. Unfortunately, lead can be observed in every kind of places in Tbilisi. On Moscow Avenue, carbon dioxide and nitrogen dioxide, and on Tsereteli Avenue, dust, carbon dioxide, nitrogen dioxide, and lead. The indicative measurements were performed in several stages. At the first stage, 11 indicator measurements were conducted in Tbilisi. Low index of sulfur dioxide, ozone, and benzene were observed everywhere. And the index of nitrogen dioxide was moderate everywhere, except for one point, Tovstonogov Street, where its low index was observed. 2018, at the second stage, 11 indicators were measured. Low index of sulfur dioxide and ozone were observed in all the area. Nitrogen dioxide indexes were both low and medium. Mainly average indexes of nitrogen dioxide were observed at 6 points. Results of indicator measurement, 10 indicators measurements were conducted in 4 stages. In 21 points of Tbilisi city, measurements of nitrogen dioxide 18, sulfur dioxide 6, ozone 12, and benzene also 12. Low indexes of sulfur dioxides and ozone were observed everywhere. The nitrogen dioxide index was low in only 15 cases, moderate in 55 cases, and high in 10 cases. The benzene index was low in 9 cases and moderate in 3 cases. The study also showed a relatively low rate of pollution in 2020, and most likely due to the pandemic-related transport ban, because due to pandemic, in some period of time, stopped utilization of every kind of transportation in Tbilisi, and maybe because of this. Based off research, the following recommendation can be made. Avoid parking the vehicle with the engine running, replace the engine air filter promptly, maintain the recommended air pressure in the tires, do not continue to refuel after the refueling devices automatically shuts off after filling up the tank, use cruise control as much as possible, which itself regulates the speed of movement, moving at low engine speeds, reduced fuel consumption. Do not preheat the engine, instead start the car and drive for a short time at low engine speeds until the engines warm up. Do not drive in summer with winter tires, minimize the use of air conditioning. The catalyst can be damaged in the vehicle is closed by towing it. Free the car from unnecessary load. Try to place the load in the trunk of the car and not on the roof, and etc. etc. But for good results, we need that everyone should be allowed these recommendations. And we will hope that in the next period of time, we will have a better situation. What can I tell, like conclusion based on data obtained? It can be assumed that the air in most districts of Tbilisi is moderately polluted. And in some cases, the data exceeds the maximum allowed norm. There may be several reasons for this: unauthorized slashing of green islands and massive construction of high-rise residential building of their place in Tbilisi, malfunctioning vehicles, the technical inspection of which has recently made stringent. However, some vehicles still polluted the air, and emissions produced by many factories and enterprises. We are going to continue, as I told. So this was an overview, just overview with some dates and some results. We are going to continue moving in this direction, and more results, I think, will be allowed when our own sensors will be installed in scope of NATO project. And after will be, so we will two kind of results by remote sensing and data obtained by our own sensors, and we will see what happened. So this is references, and thank you, obrigado, Didi Matluba.
Wow. Thank you. Thank you.
Thank you, Dr. Ketevan.
Thank you.
But how I can see everyone?
You need to stop sharing the screen.
Stop share, yes.
Perfect. I believe that people may have questions. If not, Dr.
Yes,
Argüello, please.
Dr. Gustavo has a question.
Yes, good morning. Well, thank you very much for your talk, Ketevan. I don't know whether your name is pronounced Ketevan or Ketevan, but
Ketevan,
it was Ketevan. Okay, Ketevan. So it's a pleasure to meet you, Ketevan. And yes, I have a simple question. I would like to know whether, I know that 3 years of measurement is a very short time, but do you have already something like a trend saying, for example, that the pollution problem is going down or going up?
According to these data results, it's don't going down and don't going up. It's quite still average average stage, and it's also not bad because it's not going up. But of course, our government should, and stakeholders and the decision makers should think about this, because scientists only can give to them recommendation based of research, and after every citizen and decision makers should think regarding this.
Okay, yeah, that is exactly my second question. What is the role that the decision makers are playing at this moment? So are they being very strict with the way they are working in order to to make better the quality of air?
So right now in Tbilisi, it's very hard to drive your own transport, your own car, because there is a very strict rules, and it's how to say, a person make a decision that it's better to use public transport instead of car. But still we have a lot car, but I think time and again people will think regarding this, because as I told we have a lot of cancer in the country. For example, I lost 2 years ago my mother due to this disease, and we fight a lot, but for nothing. And this is a big problem, and one of biggest reason, this is the air pollution, unfortunately.
Okay. May I still have another question, please?
Yes.
Okay, thank you. I would like to know, I'm sorry about my ignorance, but I would like to know what is more or less the geographical situation of Tbilisi, because you said that you don't have ozone problems. So is a region surrounded by mountains, or is it just a valley? So is the wind flowing without any problem and carrying out everything of the pollution?
Yes, this is cities surrounded by mountains, and a lot of in my childhood period of time, Tbilisi was a green city. Now we have a lot of building, and we don't have a green, unfortunately. And I think this is also a problem.
Yeah, I understand that this is the price we are paying for progress.
Yes, yes, this is a price.
Okay, thank you very much, Ketevan.
Thank you very much.
Thank you, Dr. Argüello, for your questions. Does the audience have any questions?
I have,
Somebody?
if I can.
Somebody can just press the button with your hand. You see that you have a lot of tools here in the Zoom. I always use Meet for do some meeting, but I can see if somebody have another question. Does the audience have another question?
Yes, I have.
Hi, sorry, I didn't see you. Just is your my co-partner, so I didn't see. Sorry, Dr. Luis.
That's not a problem. Thank you. I have 3 questions. Okay, I will ask the first one regarding the lead in the atmosphere. Is it coming from the gasoline, or it has another source?
We don't know, because so according the official data, in our gasolines we don't have lead. But at the same time, we don't have official laboratory who will control this. So
Okay.
That was my first question. Thank you. The second question regarding the investment done to create the sensor network, how much, how big was the investment?
You mean the NATO project, isn't it?
I'm not sure if it's only NATO project or if it is a national project as well.
National project. Just 1 second. Just 1 second.
Remember that we have different time zones.
National project is also financed from some international project sources, and by state also as well. But right now I don't have information how big it's.
Thank you.
how big is support, but and also what I want to say, some other groups of scientists also investigate air pollution processes in different universities, and they also have a support from international projects.
And my last question regarding the satellites Sentinel-4 and 5. They are stationary for Georgia, or we can check if it's open access, check Brazil or something like that?
But we can check in every place, and why we started to investigate it by remote sensing, because I am also involving in other in international process where chlorophyll level in Black Sea was investigated by sentinels. There is a different type of sentinels, and then we discovered that Sentinel-4 and 5P can by data from Sentinel-4 and 5P, we can investigate atmospheric air also as well, and it's absolutely free. It's a quite long process, but very interesting. So it can be receiving data from every kind of every countries.
That's very good. Thank you.
Dr. Arguello,
may I again, please? Thank you very much. Just a statement. I think I believe, I am not sure, but I believe that the satellites should be in a polar orbit, because they are passing every 60 minutes over BILISI. So they are not stationary satellites, but they are polar orbit. Okay.
So I started use this methodology with the other specialists together, and right now I'm also learning with them. So they are doing, and I am also teaching with them this methodology.
Okay, thank you.
Okay, thank you very much. And I think we can give to Professor Ketevan applause. And if you remember the audience, and thank you very much for very good. We know that the pollutants and the environmental problems are really interesting, and of course we have to take hands about that, because it's really an interesting topic. And as you remember, in the website, you have all the contacts, emails, everything, and the poster presentation videos, and also other things that you can see there. And if you have more questions, you can send an email, for example, or just to visit our YouTube channel and leave there some comments, some questions for Professor Ketevan. Okay, but again, I can say, Professor, thank you very much for your interesting conference. Really, this is a very, very important topic.
Thank you
I know
much.
that.
Thank you.
Thank you very much. I know that pollutants are very important in our life because really it's a very big problem. And in few minutes, just no more than 10 minutes, 15 minutes, we will have another important topic that will be the warming, the global warming. And this conference will be performed by Professor Gustavo Arguello, who was participating so active right now. And so we will do a break, just 10 minutes, something like that, 15, no more than that. And we will appear a presentation to Professor Gustavo Arguello from Argentina with another interesting conference. See you in 15 minutes, okay? See you, and thank you again to everybody to be there.
Thank you, Walter. Thank you very much, Ketevan. It was a pleasure to have you here.
See you in a few minutes. Thank you very much to everybody.
All in 10 minutes. Bye-bye.
Yeah, we come back.
Hello, Dr. Walter, welcome back.
Welcome back to Dr. Luis de Boni. We will start. So everybody's ready. We will give some minutes more to the people
Yes, it's too soon.
going to the meetings. Yes. I can ask to Dr. Gustavo Arguello if he's ready. Everybody, okay, perfectly. So.
Nice to see you, Dr. Zanar.
Yes, yes. I can see, oh, people from Germany. Matthias Berasategui is there. Very good. So you can start to record, Dr. De Boni, if you want.
Oh, yes. Thank you. Thank you. Thank you. Remember, I am not a professional in Zoom.
Yeah.
Now I think it's done. Or doing.
Okay. Dr. Arguello, are you ready?
Yes.
Perfect. Yeah, okay. So, it is a great honor for me to introduce to all of you Dr. Gustavo Arguello, with whom I worked for many years and who was a great mentor to me in the physical chemistry field. I want to remember you that, as I told you, I performed my career in organic chemistry at the beginning, but after that I moved to the field of the physical chemistry, and now I can say that after learning a lot of things with Dr. Gustavo Arguello, Zsolt, SZAKONYI, Dr. Gloria Iranzo, and many others, I can say that I'm physical organic chemist. Before I let you enjoy his knowledge, I would like to tell you some details about the Dr. Gustavo Arguello's scientific life. Okay. Dr. Arguello was born in 1953 in Córdoba, Argentina. He performed his superior studies at the University of Córdoba, obtaining a bachelor and PhD in chemical physics. He performed his postdoctoral studies in several foreign universities. In the USA, at the University of California with Professor Dr. Mario Molina, later Nobel Prize in Chemistry in 1995. In England, at the University of Oxford, and in Germany, at the University of Hanover, Duisburg, Essen, and Wuppertal, as fellow of the Alexander von Humboldt Foundation. His specialization is in kinetic on photochemistry in the gas phase, and his studies have to do with halogenated substances, especially fluorinated ones, with potential atmospheric impact, as well as with synthesis and characterization of new fluorinated species. After returning to Argentina and becoming a full professor, he was the director of the Higher Institute of Environmental Studies, ASIA, of University of Córdoba, and with the time, he rose into principal researcher of Argentinian National Research Council, CONICET. With his research group, he was actively interested in the environmental chemistry. For that reason, he has conducted several Antarctic campaigns to determine level of persistent air pollutants. He also collaborates in the dissemination of knowledge on topics related to global warming, atmospheric pollution, etc. During his career, he formed 12 PhD and 6 postdoctoral students. Besides, he published more than 130 articles in international journals. Currently, he is a full member of the National Academy of Science, and he is Professor Emeritus of the National and University of Córdoba. Today, Professor Dr. Arguello will give a very brief resemblance of 2 researchers that have most contributed to his career, namely the Nobel Prize awardee Mario Molina and his PhD director from Professor Eduardo STARICCO. Further, he will introduce some basic concepts of physical chemistry to understand the global warming. The title of his conference is The Physical Chemistry Behind the Global Warming, with a remembrance of my mentor, Professor Eduardo STARICCO and Mario Molina. Dr. Arguello, are you ready? The audience is yours.
Okay. Well, thank you very much for this kind introduction, Walter. And well, I hope all of you will enjoy this conversation. So I will start, first of all, changing the way I'm going to talk, because I have to put a PowerPoint.
Yeah.
That I hope you all see already. Is there?
No.
No? No
Yeah,
yet.
we will see.
How
You
can
have
I
to
do
share the screen. Don't worry, doesn't matter.
Yes.
And as you can see, both conferences, that Professor Ketevan conference and Gustavo Argüello conference, they are related. Just casualty, okay? Incredible, but the casualty exists. Maybe some assistant can help you, and just you have to reproduce the PowerPoint in as full screen.
I'm sorry, but I don't have still my presentation on the.
Did you share a window?
I think I will need some help.
Yeah.
That's the problem with the virtuality. I am not.
Yeah, we had 2 years, complicated years.
Okay, now it seems that
yes. Perfectly, doctor. Okay, the audience is yours again.
Okay, well, first of all, thank you very much to the organizers for inviting me to give this conference. As I am already retired, I am more than 65 years old. Okay, so I was invited today to my old university. So I am here, and I think I will take a little bit of the camera, because I have still the public here, which is they are part of my ex-research group. Okay, that the group is now led by Walter Peláez, by Maximiliano Burgos, by Fabio Malanca, by Ana Iriarte, and these are the people that are following my earlier job here in Córdoba. Nevertheless, I would like to begin saying that the physical chemistry behind global warming will be the main part of my talk. But first of all, I would like to start saying some very brief words about my two mentors, which were Professor Eduardo STARICCO and, as you said already, Mario Molina, the Nobel Prize in Chemistry. This is a picture of Professor STARICCO by the time I started my PhD studies, so it was approximately in 1976. At that time, many of the research lines of the Department of Physical Chemistry had, and still have, because we have a long tradition on that, had to do with the kinetics and photochemistry of gaseous fluorinated substances. And this is why Walter already told that I specialized in fluorinated molecules. Okay, so Professor STARICCO was the head of the Department of Physical Chemistry at the time, and he became my PhD director. So he was my advisor during the time I did my PhD work. Therefore, I could not escape from that tradition of the department and of Dr. STARICCO himself. And during my PhD, I began to work with fluorinated substances. The first one I took was CF3I. So that is trifluoroiodine methane. With that, I made my PhD thesis working in chemical lasers. Now, due to the scientific diplomacy of Professor STARICCO, he soon became engaged in management, serving first as vice dean of our faculty. Then he was the dean of our faculty. And later, he became vice rector first, and then the rector of the whole National University of Córdoba. Besides, he serves also in serious politics, and I would like to remark this word, serious politics, as Minister of Science and Technology of the province of Córdoba, so of our state of Córdoba. And then finally, he got back to science, where he served as the president of the National Academy of Sciences. In this picture, you see Dr. STARICCO, which is already a little bit older than the picture before. and as president of the National Academy of Sciences during my appointment as an academic. Along those years, Dr. STARICCO had risen a sound-based and well-renowned group in physical chemistry that could run by itself. So he prepared a lot of people who were able to continue working in physical chemistry without his advice anymore. But what the central point here is that Dr. STARICCO implanted in many of us the seed of scientific research, and I am a living example of it. That is everything I will say about Dr. STARICCO by the moment, and I would like to switch a little bit to Mario Molina. My approach to Mario Molina was as early in 1979. I remember he was seeking a person to work in his lab in a project involving vacuum UV fluorescence. And at that time, I remember I was working here in the University of Cordoba, and I remember two things. The first one was that Dr. STARICCO had worked with Mario Molina in Berkeley by the time that Mario was doing his PhD. And the second thing that I remember was that Mario himself had made his own PhD using chemical lasers, which was my goal in the doctoral work. Therefore, it took me only 2 minutes to go to talk with Dr. STARICCO and to get his consent to go to Mario's lab to work with him for a year. After that time and after returning to my country, I dedicated myself completely to the university and to scientific research. And I had the opportunity of seeing Dr. STARICCO getting older until the age of 86 when he died. This picture here is at the age of 85, and he was still active by that time. Well, in any case, I will not enter now in many details about the life of or the achievements of Mario Molina, because probably you all know what was his career. I would only say that I had the opportunity to present Mario Molina in our university when he was awarded with the honoris causa professorship. And this is in this picture, you are seeing Mario Molina is seated between the president of the Academy, the president of the Academy of Sciences and the rector of the university by that time. And this is Mario. And after receiving this award, he gave his talk. Okay. So immediately after this conference in the university, we went to the Academy of Sciences, where we formally signed the act of admission of Mario as an academic. Let me tell you that Dr. STARICCO had proposed Mario Molina as an academic as early as in 1999. And we had the opportunity of having Mario in our city, in Cordoba, only in 2016. So by that time, this picture is in 2016, he became actually professor honoris causa of our university and academic of the National Academy of Sciences. Therefore, after all this work, let's say, we needed some rest. And after this rest, we went for a good barbecue all together. There you can see Dr. STARICCO, Mario Molina, this is myself, and this is part of my research group that we got together in a barbecue when Mario was visiting us. Of course, I should also say that given the ascendancies that I have with Mario and STARICCO, okay, I could not escape from the gas phase chemistry, from the fluorinated molecules, and this is the reason why I feel comfortably enough to talk to you about a little bit of global warming. And now, if you allow me, let's go to physical chemistry again and begin with the problem of the basis of the global warming problem. Well, I think, yes, you can read perfectly the screen. So let me analyze the following experiment that I performed myself in an actual conference. So I put here only drawings, but this is a very simple experiment that you can do in only 15 minutes, okay, and take a lot of interesting results. So let's turn a heater, okay, a home heater on, and let the radiation fall onto a metal sheet, okay? After that, we can measure remotely with the infrared sensor, okay, the infrared thermometer, we can measure the temperature as a function of time. Now the question is, how will the result appear? What is what you think that will happen when we heat this metal sheet with the heater? Well, I will tell you what is the result, because we don't have time to repeat the experiment, okay? But I will resort to Excel, okay? And in this Excel screen, you can see what is the result that we expect when we heat the metal sheet with the heater. Of course, the temperature rises. I don't know whether you can see the pointer, okay? But the temperature rises when the heater heats the metal sheet. And the question now is, how long will this temperature goes up? Will the temperature reach a value that will melt the metal sheet? Well, think about that. And you have 3 seconds to get a response. In those 3 seconds, I will give you the real response, because I will put already the results. Okay, if you allow me to do this, I would put here the results, and there you have the results, what really happens. So the temperature will not go up infinitely. The temperature reaches a top value and reaches a constant value. It reaches really a steady state. Why is that reaching a steady state? If the metal sheet is continuously receiving the heat from the heater, and the answer is that it reaches a limiting temperature, a steady state situation, because the metal sheet itself begins to radiate the excess energy or the energy which is receiving from the heater. And this is exactly equivalent to what happens. Let me do this, please. This is exactly equivalent to what happens with the system. What happens here? Let me know. Sorry, it's a little slow, the system. I think I'm going too fast. And this is okay, there. Now, next, okay, there. So I said that this is exactly equivalent as the system. The radiation that the sun shines all through the space, okay? And the Earth has been receiving that radiation for hundreds of millions of years. So why the temperature of the Earth has not increased until melting, for example? The answer is the same as before, because the Earth radiates the energy that is receiving from the sun and reaches a thermal balance, okay? So it's a thermal balance, it's a steady state situation. Now, I don't know whether it's slow the TV set that we have here, or is slow the transmission between the assistants to the conference, but in any case, I will slow down a little bit until I see in the screen what is going.
Okay, don't worry, something happened, sometimes happen, that kind of things. Maybe could be the internet. You remember that the internet is a problem in that virtual conferences. And if you want, you can switch off your camera, and maybe the internet will be more.
Okay, I will do
But
that.
you are frozen. I can see the image of you, and you are frozen. Maybe if you switch off the camera, and it will be faster. But something happened. It's the internet.
Okay, so
I can see that your mouse is moving. Your mouse is moving. Okay, perfect. Continue.
good. So that is what we can see, what we should see. I don't know whether you are watching a screen which is very colorful, okay? And here I will put a graph, a plot of what is the radiation emission from the sun. So I will plot what is the energy that we receive as a function of the wavelength. And let me explain a little bit what is the picture here. So I try to make, as a function of wavelength, to put the colors that they represent. For example, at short wavelengths, we have the violet color because it resembles the ultraviolet radiation. Then we have the visible colors, okay? And then we have a pale rose here, which means that this is all infrared radiation, okay? So if we assume that the sun is functioning as a black body, okay, as a black body, and that its temperature is really high, so around 5,800 Kelvin is the temperature that the sun emits. It's not the actual temperature of the sun, but it's the temperature that reflects the way the sun is emitting radiation. And I will put here, as you can see. Can you see already a plot here, which is
No. We are seeing the graphic with of the world, the radiation from the sun, thermal radiation emitted by Earth. I can see the photograph, the graphic.
Here. Okay. It's. I'm turning it down.
Okay, everybody's slow.
I'm sorry. I'm turning down my camera so that I can speed up.
Okay.
Sorry. I told you already, I am not acquainted with these virtual conferences. Yes.
Yeah, the time are changing continuously. Yeah.
I don't know why it's taking so much time.
Worry, it happens. We are very far apart and internet communications are not so good sometimes.
Yeah. Sure.
Right. Oh, I have a warning here that says that the Zoom meeting does not respond.
Okay.
Can you still hear me?
Yes,
Yeah.
perfectly.
Perfectly.
You can hear me, but you cannot see my plots. That's a big problem.
This is a problem with the
Maybe you
computer.
can stop sharing the screen and start it again.
To start again. Okay.
The sharing of perfect.
No. It's okay. The plot is there.
Yes.
The plot is there already. Okay, good. So this plot that you see here is the emission of a black body at 4,988 degrees centigrade, which is a little bit less than the temperature that the sun actually emits, okay? But you can see here two things, important two things. One is that the area under the curve is the total amount of energy that the sun is giving to the earth. And the second one is that the maximum of the curve here is around just in the limit between the visible and the infrared region of the spectrum. But if we raise the temperature at the value that the sun should have, okay, you can see again two things, that the total amount of energy has increased and that the maximum of the curve has shifted toward visible radiation. And the maximum is right in the green-yellow, the yellow-green wavelength, okay? So this is the way that we perceive the radiation that is coming from the sun. It acts like if it were a black body working at 5,800 degrees centigrade. Okay?
Okay.
No, I need to go back here.
Okay. I think you have to cancel that because they cancel or not.
Okay, so now let's go to see what would be the radiation that the Earth should send to the outer space, okay?
Okay.
Acting also as a black body. Because remember that the system Sun-Earth was in a thermal balance, okay, was in a steady state. So all the energy that receives the Earth from the Sun should go out to the outer space, okay? And here is a plot again as before, okay, but as the Earth is at only 200 or approximately 300 degrees Kelvin, okay, so approximately, okay, so all the energy that the Earth is sending to the outer space is located exclusively in the infrared region, okay, exclusively in the infrared region. So the Earth emits infrared radiation and nothing else, okay? Now, if we put the two plots together, okay, so if we take a look at the two plots together, we immediately have a picture that tells us everything about the global warming. We receive visible radiation from the sun, and we emit only infrared radiation from the Earth. And here you have the situation. So this plot here is the radiation we receive from the sun, and this plot here is the radiation that goes to the outer space from the Earth. One is in the visible region, the other one is in the infrared region exclusively. And this is the problem of global warming, okay? Now, let me show you now what would be, or what is the actual picture of the Earth in terms of the radiation going to the outer space. So if we take a look at this plot, do we have the plot yet? No, not yet. Okay, wait a minute. I'm sorry about these delays. I can see everything in my computer, but okay, now we have the plot over there. Okay, so if we take a look at this blue line that goes here, this is a plot which is the radiation flux that the Earth emits as a function of the wave number, okay? So if we see this is 100 kilometers of altitude, and the blue line corresponds to the radiation that the Earth should emit if it were not have any atmosphere, okay? But we all know that the Earth has a gaseous atmosphere, and this atmosphere is composed of several different gases, of many different gases. But let's think for a moment, what would happen, for example, if we put some ozone in the atmosphere? And if we put some ozone in the atmosphere, we immediately see, not so immediately, but in a few seconds, I hope you will have the picture. There it is. Okay, so if we put the ozone in the atmosphere, we immediately see that there is a peak here, which tells us now that the Earth is not sending out all the radiation, because some of this radiation is absorbed by the ozone. We know, for example, that there are some methane also in the atmosphere. And if we put the amount of methane which is in the atmosphere is 1.7 parts per billion, okay? So this is the actual concentration of methane in the atmosphere. We also see that there is another region in the infrared radiation which is not coming out because the Earth is, the methane is absorbing that radiation. And if we know that the problem of the global warming is due mainly to the carbon dioxide concentration in the atmosphere, we are going to put some carbon dioxide in the atmosphere. And we are going to put the amount of carbon dioxide which was present in the atmosphere in 2010. And there you see immediately that this is the biggest responsible for the problem of global warming, because carbon dioxide itself accounts for almost 60% of the problem of global warming, because all this infrared radiation that you see here is not going out because the CO2 is absorbing that radiation, okay? But we can also see in this plot two regions from beginning here and ending here, okay? And this other region beginning here and ending here, which are free from absorbing species. Let me take a minute and then we will come back to this. First, I want to tell you another thing. I think you all already know that this plot, okay, this is a very well-known plot of the progression of the carbon dioxide in the atmosphere. This is called the Keeling curve because of Ralph Keeling, which was the leading, which was the leading scientist at the Mauna Loa Observatory in Hawaii. He measured the concentration of CO2 continuously, day by day, since 1958. So when I was 5 years old, he has begun to measure the CO2 concentration. And as we can all see here, even though we have a seasonal variation of the concentration, because it goes up in winter and then it goes down in summer, during the summer, because of the activity of the trees, okay? But the trend in the concentration of carbon dioxide is continuously going up, And we have here measurement until 2021. Let me show another interesting, this is a movie, okay, that I took from public agencies, okay, which is the evolution of the CO2 in the atmosphere, okay? And it shows, as soon as it begins, I will tell you what it shows. Sorry about the delay. Okay, now we have. So let me explain a little bit this screen. In the map that you have here, you have a red point which signals the Hawaii, okay, so the Mauna Loa Observatory. The blue dot, which is on the bottom, is the station, the polar station at the South Pole. This is the McMurdo station. And all the gray and white dots are other measurements in different locations in the world. As this clock, let's say a clock, will run, okay, we will go from 1981 to today, almost today, and we will see at the same time how the concentration of CO2 is changing in the atmosphere, okay? So it's, and here at the bottom, in the right bottom, where I don't have the pointer. Oh yeah, I have the pointer there. Okay. So here you can see what is the daily variation, okay, of the CO2 concentration. Okay, this will take a little time, but be patient because we will have some surprises here. First of all, the first surprise is that since October 1989, the people in Mauna Loa Observatory did not see any more a concentration of CO2 less than 350 parts per million. Okay, so that is a very big problem. but the concentration still goes up, okay? And today we are reaching how much? We are almost here, 380, and we go, it's delay, we have delay. Why is that not working? Oh, okay, that is working. Okay. So you see that we have already passed 350, we are approaching 400 parts per million, okay? And this is almost a catastrophe. And here we have end with the concentration, with the actual concentration. But now let's see this green part, which is going back in time. That is the first points of the Killing curve, when Ralph Killing measured from 1958. But let's see what happens if we take another data, which is in the ice core, okay? And this information, which goes back in time for many, many years, tell us that in just a few seconds, talking in terms of geological eras, okay, in just a few seconds, we have risen the amount of CO2 in the atmosphere. So this is a picture which takes all the data which was taken and goes back to 800 years. 800K years. And we can see here very clearly that never the concentration of CO2 was as high as the concentration we have today. Okay, so that is our problem to have this. It is our problem and we should fix it. We should fix it. Now, let me tell you another bad thing. If we go and take a look, what are the fluorinated molecules doing in the atmosphere? Okay. I will go again to my picture of the radiation which should go out to the outer space from Earth. Sorry, allow me a minute. I have to put this Excel plot again. Okay, there we have. So we already know what is the black plot that we have here. And again, you can see here what I told you before, that we have two regions, okay, which are called the atmospheric windows. In those two regions, there is no absorption of natural molecules, okay, but all the fluorinated molecules that we put in the atmosphere, and I am not talking about the ozone problem right now, but just about global warming, okay? All the molecules that we have put in the atmosphere that have chlorine and fluorine atoms in their compositions are making that the atmospheric windows that we should keep wide open in order to get rid of all the excess energy is not becoming like that, because if you increase the concentration of one of these chlorofluorocarbons, for example, you immediately see that the region which is being compromised is the region of the atmospheric window. So this is a bad news, and we should keep the concentration of all these substances as low as possible. Of course, the Montreal Protocol has done a very great job about the stopping the production of CFCs and eventually banning the production of CFCs. But we still use another type of substances which are called the CFC replacements. One of them is this one that I put over here, okay? And this CFC replacement have the capability of react in the troposphere, because these molecules are very similar to the CFCs in terms of refrigerant power, but they have at least one hydrogen atom which is labile and is easy to be attacked by the hydroxyl radical of the atmosphere, okay? And when it is attacked, it begins the decomposition here in the troposphere. So this is at low altitudes. But some of these molecules also have a lifetime which is not in terms of seconds. They have lifetime of days, months, years, and if some of them enter into the stratosphere, which is a dry region of the atmosphere because it has no water and therefore it has no hydroxyl concentration, measurable hydroxyl concentration, then these molecules, when they enter the stratosphere, they can act as global warming issues, okay? And this is the reason why these fluorinated molecules have so high global warming potentials, okay? Well, let me just finish putting just the title of an article, which is not very new. It's 2019, that was written by Kate Marber, and that says that talking about global warming, how hot exactly is it going to get? This article works with a lot of numerical computations, okay, using computational programs. And the problem is that when we use the climate models, all these climate models, like all models, are imperfect representation of the real world. Let me just read what I have written here. These programs tell us something useful about the planets we are changing, but not how much exactly we will change it. So that is a problem. The only way to be sure is to actually double the atmospheric concentration of carbon dioxide and wait until the planet approaches a new steady state. In the way we can measure, of course, every day the concentration of CO2 until it reaches the new steady state. But what will happen if we do that? This is an uncontrolled experiment, and I hope that we will never do it, okay? But in terms of what is happening right now in our Earth, I am afraid that we are well on the way to doubling the concentration of CO2 to find out what is going to happen. So this is my talk, and I think that I have to tell you only thank you very much for your attention. I have to thank also all the agencies that make available all this data that I took and I collected to give this little talk. Thank you very much.
Well, thank you to you, Dr. Gustavo Arguello. True, it is a very interesting, and really I am worried, of course, because it's incredible. I want to say something before to go to the questions. I don't understand why still people saying that the global warming is just a lie. There is a very hard, there are a lot of proofs that say that it exists, but I don't know why still people saying that it's a lie. Okay, does the audience some questions for Professor Arguello about the warming, the global warming? And as you see, it is very, very related with the conference of Professor Ketevan from Georgia, because what happened with the pollutant and what happened with the particles in the air. Okay, somebody have questions? I can see in the chat something.
I have a small contribution. It's very small, but I remember when I worked with Professor Ionescu, he used to talk about Professor Molina. So now, what a coincidence.
Yeah, okay. It's good to know that you also knew about Mario Molina. That's
Yeah.
Yes, many years ago.
Yeah, yeah, it's incredible. True, really, this is a very, very complicated situation for our world. But I don't know if one of the things is at what temperature will we arrive? Because as it's true that Professor Arguello said, okay, which will be the new stationary steady, and which will be the temperature? I exactly don't know. Really, I don't know, and it will be complicated for the Antarctic. For example, I remember when the professor go there to the Antarctic to do some exploration about the contaminants there, the pollutants there. And I don't know if you go again, you will see the glaciers and the things are the same that you see, and you took pictures just some time ago. Really, it will be melt, or great part of them. So somebody have some question. Remember that you have the emails in the web page. You have the emails, and also you have the YouTube channel. You can leave their questions or inquiries, it's possible, by email or by the channel, okay, YouTube channel. The Professor Luis de Boni, how it will continue. And we can say, of course, before leave, thank you very much to Professor Gustavo Arguello, because really it is very interesting topic, and I think that we have to notice of this. The people have to notice that the global warming is a very big problem for the country. Thank you very much for your kind presentation, and don't worry about the delays. It's always happened just in this time of virtuality. Don't worry about that, because it was perfectly, we can understand, I understand very well the things that you want to transmit to everybody.
You should understand everything, Walter.
I know. Yeah, the black body always have my problem. I remember when I arrived here to work with you. Okay, Professor, again, thank you very much. And we will think, I will do a break. That is true, Professor Luis Casadeboni.
Yes, it's true. Let's make about 2-hour break, okay, for lunchtime. Remember, it's Brazilian Standard Time. So I also would like to say thank you to Dr. Arguello. It was a pleasure to meet you. I hope that next time, if God allows us, we may be together in Argentina and have a barbecue.
We hope.
I see the picture.
It will be my pleasure to meet you here in Argentina. Okay, and let me just say that I am the one that should be grateful for this invitation. Thank you very much.
Thank you to you, Dr. Gustavo Arguello. Okay, so people, we will see you in, I think, 2 hours or something like that.
About
Dr.
2 hours.
Deboni, check me the time, please. In 2
Perfect.
hours.
2 hours from now, a little bit less, 1 hour and 40 minutes, but who cares?
Perfect.
We will be here. I will leave the clock on the screen. Okay.
Okay.
So see you all soon. Thank you very much. Bye-bye.
Thank you very much to everybody, and see you in a few minutes. Bye.